Even here in like Long Beach, California, LBC, there are Michigan alum. So they have been really key in like pushing me outside of my comfort zone, helping me to be comfortable with being uncomfortable, especially in a technical domain, being willing to help me like become like the best engineer that I ever wanted to be. So I graduated from the University of Michigan College of Engineering in 2016 with a bachelor's in materials science and engineering. And then I got my graduate degree in space systems engineering in 2019. So it's been not that long since I got my grad program. I currently work for the Boeing company. I am in their kind of like early career talent pool. They have a really top-notch rotation program that I'm in right now. It lasts 2 years total. Each rotation is 6 months long, and we rotate throughout all of Boeing's business units. Last July, I started in a service engineering team in Seal Beach, California, working and supporting the 737 MAX program. My second role currently, that's what I'm doing right now, is in space systems engineering, specifically mission architecture engineering. And I'm supporting kind of this Pathfinder project at Millennium. I'm not sure how much I can really talk about in terms of like the satellite that we're supporting, but it's all about model-based systems engineering. It's really, I guess the way to kind of like describe what that is like, how back in the day, if you wanted to design a part, you might, hand draw it. But that all changed when we started implementing computer-aided design, right, CAD. B.S.E is the same kind of application, but for a systems engineering domain. So working through, you got this product and you've got a bunch of requirements, and you need to make sure that the thing that you deliver to the customer, whoever they may be, actually fulfills all of your requirements.
But can you just share one of the most exciting parts about the rotation you're on?
When I was actually able to understand how this modeling and simulation tool, Cameo is what we use, felt like, I don't know, I felt dangerous. I felt like, you know what, I now know how to use this, and I know how to use it to address the problems that we have. And so I'm gonna just like start running for it. Once I was able to get into the model, we were able to start, creating use cases, right? Use cases that showed our architecture. Like, you have this satellite, here are, 15 different ways in which you can use it. We started to have a model. We really started to have a architecture model of a satellite. We were able to see how it worked. We were able to involve all of our stakeholders. We were able to kind of evaluate a working ground system, right? Not just like the satellite floating around, in space, but how does it communicate with all of these different terminals that are, all over the country, right? Like, how do we coordinate that effort so that we're not losing communication? We're actually able to implement, our mission objectives, like all those kinds of things. Like, we are now able to see and say, this is how we're going to do it. And so for me, a really exciting part was being able to like work with my team and achieve that success, right? When we were able to baseline our architecture, right? We all took a day off. We're like, awesome. We're like, we did it. Like we were able to kind of get to a point where we're able to deliver like real life value for a program when we started from like zero.
So how do you see your work, or how might your work make a difference in society?
There are so many ways in which like the aerospace industry kind of affects life and affects the world. But I got to go see, go to Southwest Airlines. I got to go to Dallas. I got to sit in their headquarters. I got to watch them take planes apart. It's crazy to like think about, how the work that you're doing has impact. It has an impact like that, right? And even working in the satellite space, Boeing is working on, this huge project called O3B, stands for the other 3 billion, providing internet to like people all over the world who have never previously had access. And I just think about how the internet has been so key in my own educational career for various reasons, mostly Google, but like it's been so important. And so thinking about how that can have an impact for people all over the world is like pretty sobering, right? Because all I'm doing now is, working in this model. I think I'm so smart, yada, yada, yada. But it has an impact to really like dramatically change someone's life, the work, that I'm doing here.
Why did you decide to study engineering?
So there were a lot of things that led to my decision to study engineering. Originally, when I was in high school, I thought that I was going to apply to U of M as like a biochemistry major. And it wasn't until I got involved in robotics in high school and, being involved in that group, they saw that I kind of had a talent and knack for it. So they recommended that, since I'm applying to colleges, that I try to, get into the College of Engineering, and that, if I hated it, I could switch out, but they said that it could be a good fit for me. And so
I really relate to that whole high school thing. I definitely was not planning on becoming an engineer until I joined robotics. So
yeah, I feel like a lot of people have a similar kind of journey and story. And so that's why it's like really important that when you have the opportunity to reach out and to talk to other people about engineering, especially like women of color, women in general, and just, recommend that, people just check it out. What's the harm, right? And just checking it out.
You just graduated in 2019, so I guess your career is very early in its stages, but can you kind of talk about how that all went?
Yeah, so I, like I mentioned before, I came in and chose material science and engineering for my undergrad. I really enjoyed material science and engineering for a lot of reasons. One being because I like knowing kind of how things work on a molecular level, right? Being able to take a material, break it down, understand its inner workings, and more so kind of find applications for those materials are things that I'm really interested in. And I realized that the coolest applications were in the aerospace industry. And in college, I joined a design team called MIGHTY, and it stands for the Miniature Tethered Electrodynamic Experiment. That was kind of sponsored through the Aerospace Engineering Department and Electrical Engineering, and I totally loved it. I was working on a project developing coatings for solar cells, and so that kind of got me thinking, I'd really love to kind of transition into aerospace materials, right? I talked to some folks who were in the Space Systems Engineering master's program through the class department, and I started kind of doing some research into that. It seemed like a really awesome fit. And so I was in the master's program under Milton Renaud, really great professor. I learned a ton through that program, and definitely it helped me to get the job that I have. I, have been able to work on the 737 MAX program in a time that's been very difficult for the company. I've been able to work with, Southwest Airlines and FAA to recertify some of their angle of attack and air data and navigation tools. I have, I'm currently working with Millennium Space Systems, which is one of their newly acquired subsidiaries, implementing model-based systems engineering, which is kind of at the forefront of the field right now.
So what are you most proud of from your career so far?
I'm most proud of myself for really, truly believing in myself and being unafraid to have confidence in my abilities to be like a really dang good engineer. And I'm going to keep on kind of moving toward that and trying to be the best engineer I can be.
Well, what advice would you give to current or prospective engineering students, especially from the major that you graduated from?
Just because you're taking classes in like polymers and composites and, electronic materials, right? Photovoltaics, all that kind of stuff, does not mean that you have to get a job that is only working with that one material. Material science and engineering is such a treasure trove of like interdisciplinary experience and understanding of materials that can really be applied anywhere. I kid you not. You just have to look for those opportunities and be unafraid to pursue those activities, because if you're a material science person that's applying with all the other material science people, maybe your resume might get lost in the crowd, right? But I was one of the very few material science people that were applying for jobs alongside aero and mechanical, majors. And I really believe that allowed me to stand out in a way that I wouldn't have been able to stand out otherwise. And so my advice to you is like, be okay with standing out, because I don't know, I think that it's worth it, especially in this day and age. It's okay to be unique. You can do it.